Okay, I'm recording this, and we will first look over this really quick, and then we'll grab those sheets I handed out the other day and go through that free response stuff. But okay, what happened to the diagnostic that I just had here? Undo. Didn't I just have a diagnostic test up? Oh, undo. There it is. Okay, most of you got this first one right. What did you have to do? Oh yeah, I guess you could put it straight into your calculator and then just take the answers and plug them in. Or you could take the first derivative of each and then go, well, yeah. Oh, sorry. Screen is frozen. So I would, if I were you, I'd put it in your calculator and figure out which one works. Okay? So, because this is a calculator one. And we'll see, right? Okay. The next one. Okay. So the volume of a cube. The volume of a cube is the side cubed. So if you take the first derivative of that, dv dt equals 3s squared ds dt. Okay? 3s squared. Oh my goodness. Hello. I'm all right. What's up? Okay. Yep. Yeah. We'll just make it work that way. Cause cause Joey couldn't drive the big coach, so yeah. The big coach, yeah. The big coach. Yeah. Yeah. So yeah, send them with the new mini coach and they'll just have to pack on there. Ooh, and carts and ooh, jeez. I wonder because there's we maybe might have to. Where are they going and what time they leaving? Leaving at 1, going to Hartford. I wonder if you could send a driver, drive them down, drop them off so they have enough room, bring back the bus, and then after the route, go down and get them and bring them back. Because that way they would have enough room to get everything down. I know, I know that's not the perfect situation, but I don't know if she is available to run down. Yeah, and we are out of subs probably for today because so many people are gone to track. So so let me call Tara quick and see what she's got up for this afternoon, and then we'll go from there. So I'll check with her first, and then we'll figure it out. Right, if we absolutely need to do it that way. But then that's taking bus 2 times and all that too. So if Tara's available, that might be better. So all right. So
What are you playing?
yeah.
Are you competing against anyone?
All right, sounds good. Okay. Bye.
Yeah, it is.
All right.
I can just draw myself to your spot. You don't
No.
have to worry about that.
You can't. Well, hello. Do you know what room Mrs. Leasinger is in right now? So Boyd. Okay. All right. Thank you.
Who's the random?
Hi. Can I talk to Tara, please? Hi, Tara. What's your plans for this afternoon? I think so. Right. We'd have to find a sub for you. Because we've had a bus malfunction, and so we need Joey to drive the new mini coach and you to drive something like a van or a Suburban, or well, we might be out of Suburban, so a van down. Okay. Crap. Okay. So, all right. We'll see if we can find Heidi or somebody, Fods or somebody. So, okay. Thanks. Bye.
I don't know, like, the culture's out there. Is that what it is?
I don't know.
You don't play. Here we go. So this is like this. And then if you stick the numbers in, dv dt, dv dt, they tell us, right? So that's 10 equals 3 times 30 squared ds dt. The change of the side with the amount of time. So 10 over, and then 3 times 900 is 2700, right? So that's what ds dt is. Now, it says how fast is the surface area increasing? So the surface area of a cube is 6s squared. So dA dt, the amount that is changing, equals 12s ds dt. So dA dt equals 12 times 30 times 10 over 2700. And if you put that into your calculator, you get 4/3. Okay? See how that works? Okay, this one, put straight into your calculator. Let the calculator do it. What do you get?
729 over 4.
There you go. All right. This one's a nasty one. So you have to find the derivative of the inverse of x at y equals 15. And I had Mrs. Yankee tell you that you're supposed to find the derivative of the inverse because they forgot to put that in there. So 2x squared minus 3x plus 6, you set equal to 15 and you solve for x. Okay? So 2x squared minus 3x minus 9 equals 0, factor. So it's 2x and x plus and minus 3 and 3. So you get 2x squared minus 6x plus 3x, which is minus 3x minus 9. So x equals negative 3 halves and x equals 3. Now, for the inverse of the function, it's 1 over the first derivative of x. You always take 1 over the first derivative. So it's 1 over, the first derivative of this is 4x minus 3. And you check these 2 points in there. So if you put negative 3 halves in there, you get negative 12 minus 3, which is negative 15, which is one of the answers. If you stick 3 in there, you get 12 minus 3, which is 9, which it is an answer, 1/9. Okay? So when you do a first derivative, it's 1 over the derivative, but you have to solve as you go. That one was a nasty one. Okay, this one, you graph this on your graphing calculator and find the maximum. And that was at 2, right? 8? Negative 1, 8. Because the maximum value, that's the y value. Okay? So, continuing on. Find the volume of the solid revolution over the x-axis. So it's the integral from 1 to 3 of pi r squared. Okay? And if you do this on your calculator, you get which one? Yeah. Here.
I didn't use my calculator.
Okay. So it's alpha F2, 4. It brings up that. So you go from 1 to 3 of, and this is x to the 4th, because x squared is x raised to the 4th of dx. And then since the answers are all in terms of pi, you don't put pi on your calculator. You just hit enter. 48.4. If you say math, turn it into a fraction, please. 242 over 5, and then throw the pi behind it. Total calculator problem. Okay? The average value of a function, you have to divide. The average value of a function. So then this is the integral of the square root of 1 plus x squared x dx, right? Well, what's the first derivative of 1 plus x squared? No, Alex, listen to me. What's the first derivative of x squared? 2x. So you need a 2 here, which puts a 1/2 in front. And then when you're doing average value, you divide by 5 minus 0. Well, if you divide by 5 minus 0, that's also taking it times 1/5. 1/2 times 1/5 is 1/10.
That's not the answer. The answer is C.
Oh, okay. Sorry. I looked at that wrong. Okay? So it's just that. It's 1/5 of the integral of that. Oh, yeah. That one, it's the integral from 1 to 5 of 1/5 of that.
Yeah.
So you don't do with like.
You really don't have to do anything for that. You just have to be able to set it up.
I plugged it in my calculator and then I divided that answer by 5 because I got 43 blah blah blah, and then I divided that by 5, and then I put that into my calculator, and that's what I got.
So C is the right answer?
Yeah.
Okay.
I should.
All right, on this one, if you take the derivative of an integral, that's the fundamental theorem of calculus. So you put 2x cubed minus 3x cubed times the first derivative of the number up there, which is 3x squared. So it's 2x cubed minus 3x to the 9th times 3x squared, which is 6x to the 5th minus 9x to the 11th. Okay? Fundamental theorem of calculus, you got to remember to take the first derivative of that thing up there after you plug it in. Okay? All right. Left-hand Riemann sum. And there's 8 subintervals, so this takes a little bit. But it's 1 times 2 plus 2 times 7 plus 1 times 10 plus, and so on and so on and so forth. And what do you get? 137. Okay? So, yeah. On this one, the first derivative of this is the quotient rule. So it's 2x squared times the first derivative of the top, which is 3 minus 2x, minus 3x minus x squared times the first derivative of the bottom, which is 4x, over 4x to the fourth. Okay? And then you do the math, reduce, and what do you get? Okay?
There's a question for you. How much time will we get per question?
For these, this is a half-hour section for 15 questions, so that's 2 minutes per question on this. The first part is an hour for 30 questions. Yeah, 2 minutes per question, I think, on each of the first 2 sections. Okay. The differentials, what I would do is just do the math and see which one is closest, which was 140. Okay? The way to do it, though, I guess, is take 5 to the third plus the first derivative, and then, so it'd be, yeah. So it'd be 3 times, okay, so it's 5 plus 0.2, basically, to the third. So 3 times 0.2 to the second times, it's just crazy. So just do the one that's closest. Continuous at 1. You stick the 1 in for x because you want 1 to be x both places. So a times 1 squared plus 2 should equal 1 cubed minus 1. So a plus 2 equals 0, so a equals negative 2.
Interesting.
So you're sticking, because you want it continuous at 1, so you just stick 1 in for x and solve for a.
I did that in a very complicated way.
I took the first derivative.
Yeah, yeah, and
I very complicated that one.
yeah. Acceleration is given like this, and so you want the position, so you integrate acceleration. So it is 2t cubed plus 4t plus c.
Minus 4.
Oh, it's my fault. Okay. You got to write it down right.
Yep, I got that so far.
So 2t cubed minus 4t plus c. At the velocity at 2 is 9. So you say 2 times 2 cubed plus 4 times minus 4 times 2 plus c equals 9. So then this is 16 minus 8 plus c equals 9. So c must equal 1. So it's the integral of 2t cubed minus 4t plus 1. If you integrate that, it's t to the fourth. So it's 1/2 t to the fourth minus 2t squared plus t plus c. And the position of the particle at 4. So and the initial position is 1, so t of 0 is 1, so that would be plus 1. So then you stick a 4 in there, and you get
101.
101.
Position is one, so you know it's what C.
Yeah.
I think we all read this a little close.
If this is position, what's the velocity? So velocity is the first derivative position. So it's 12t minus 4 at 2 seconds. Put the 2 in. 24 minus 4 would be 20.
Okay, I have a question.
What do I
So it goes
Position, velocity, acceleration in order. Yep.
Wait, can you go over them again?
The first derivative of position is velocity. So this is a velocity function. And you just stick 2 in for the velocity. First derivative of position is velocity. Second derivative of position is acceleration. Okay? All right, this one. So, what's the first derivative of secant? It is secant tangent. So, if it's secant tangent, then u equals secant of x, du equals secant tangent. So really, we have the integral of u squared, not u cubed, because one of the secants we have to leave for the secant tangent du. So if you integrate u squared, it's 1/3 u cubed plus c. Well, 1/3 u cubed plus c is a. Okay, so that's how to do that one. Okay, you got to know the 6 trig functions for derivatives, and their opposites is their integrals. So you don't have to memorize them both. You just have to memorize them one and know they go backwards for the other one. Okay, and know your inverse trig integrals over there on the board. Okay, some of those things you need to memorize. Also the first derivative of a to the x, first derivative of the ln of x, a couple of those things you need to memorize. Okay? All right, next thing we're doing, get out the packet that you got the other day.
This one?
Yep,
The smaller one, right?
the 2015 free response guide, free response questions. Open that up. Boom. Yeah, absolutely. Keep them. Use them to look over this weekend before Monday.
Wait, are we taking 3?
They are taking the test on Monday. You and me are just hanging out together Monday and talking about your final test.
Okay. When am I taking it? On Monday? And the other week? When
Yeah, yeah.
Or Wednesday? Because what am I doing on Wednesday?
Wednesday, I don't know.
So what
We are on that Wednesday. We're turning in graphing calculators.
Isn't it probably both?
Yeah,
Yeah.
yeah. So we'll figure it out, Anna. You don't worry.
Starts right
What if we
after
bring
our-
food
I
and
don't
get
have
extra
to come
credit
on Monday, right?
on Wednesday?
Because I have some
No.
tests on this week.
Yeah. What Monday? What?
Monday we're
After
taking
the
the AP
test.
Calc test.
Okay.
Are we gonna do it now?
Yeah, but you just get your other work made up and stuff like that from missing the test. Okay. So you don't have the answers, but here are the answers. Okay? Okay, just relax. Whoa, relax. Breathe. Okay. Rainwater flows in a pipe modeled with that function at feet per hour measured in hours. The pipe is partially blocked, allowing the water to drain out the other end of the pipe at that rate per hour. There are 30 cubic feet of the water in the pipe at time equals 0. Okay? So it says, how many cubic feet of water flow into the pipe during the 8-hour period? If it's an amount, what do you have to think in your mind of calculus? Integral. So if you write the integral of the time from 0 to 8 of the rate, and you can put that down if you want, but the integral, and then you figure out the answer. Even if you don't figure out the answer, you got one of the 2 points for that part of the question. You just write down the integral. Yep. This part, yes.
Wait, so
Yep, this one would be a definite calculator question. They aren't going to give you a question like this without allowing you to use your calculator. Plug in.
Okay.
Yep. Yep.
Just plug
And
in
I'm
and
finding
solve.
76.
Yeah.
Wait,
So it's the integral from 0 to 8 of 20 sine t cubed over 35 dt. And then if you do that and you plug it in and you get this for an answer, okay, that's what you need. What?
Feet cubed, is that your label?
And that would be
Feet per hour, yes.
cubic feet. Okay. How many cubic feet of water? So it'd be feet cubed, not per hour. Because it asks how many cubic feet of water. They ask for the amount that flows in during that 8-hour period. So it'd be feet cubed.
How much time do we get on these ones again?
2 questions for 30 minutes and 4 questions for an hour, I think. The other 4.
We gotta do 6 of these?
Yeah, you've got 6 total of these.
That's it?
For
How
whatever.
long's our?
So it's 15 minutes a question. So you gotta fairly hustle. And know that the first couple are easier than the last, and the last one's usually really tough. And as long as you throw down either an integral of that or a derivative of that, if you kind of figure that sense out, you're probably going to get a point out of that one at least. And you're trying to get, most of these are worth 8 to 9 to 10 points. You're trying to get half the points. And just by throwing an integral down, you're getting a point. Okay, understand that. By throwing an integral that makes sense. I mean, not just an integral central and stopping. But that's what we got. Okay.
Can you scroll down to the,
Okay.
so we can just write down?
Yeah. You can write a little bit while I'm on the phone. Hello. Okay. Terrace covered. Yep. So. Nope. So if you talk to Stan and we got Tara covered, then we should be good. So, okay. Sounds good. Thanks. Bye. All right. Whew. Okay. So the second one isn't really all that much calculus to it. Okay? The amount of water, is the amount of water increasing or decreasing at time equals 3 hours? Give your answer. Well, if you find at 3 hours what R is, how it's draining in, and if you find the draining out rate, okay, it's draining in at a negative number and draining out at 0. So
you can just
So-
put 3 in for both of your equations and
yeah. And so this one, they don't ask a non-calculus question very often. But this year they did, and so I don't know if I would get much of that many points there, but this is what they asked. So you have that in front of you. Okay? Now the next one says, at what time during those 8 hours is the amount of water in the pipe a minimum? Okay? So again, this is an amount, okay, of water. So you started with 30. And then the amount of water is the water draining in minus the water draining out. Okay?
Can you zoom
And-
in a little bit on that?
Okay? So when the water draining in minus the water draining out is 0, is that time equals 0 and 3.27.
Could you just plug that integral into your calculator and then
But what is
go to
that?
graph and then just do minimum?
Yeah.
But you still need to be able to justify it.
or your
I wouldn't use
justification
my
is to subtract.
calculator, I did this.
Yeah.
That's what my
My
justification
calculator
Excellent
is this is right.
justification.
Now, this is a problem that I don't think I do all that well on because of the way they ask the questions. Okay? So the biggest thing you got to do is when you see an amount, throw some sort of an integral around, okay? And hopefully you can get a point out of that. Okay? And the last one, the pipe can hold 50 cubic feet of water before overflowing. If the water continues to flow in or out, how would you be able to figure that out? Well, if you start at 30 and from 0 to whatever time you're doing the in minus out, at some point you get to 50. And then that time there, that time that you hit it would be when it overflows.
Where did the 30 come from?
The 30 is the pipe had 30 in at the start. Okay? So,
Oh, it's there.
Okay, go back.
yep.
So I still don't understand.
This one's harder to
You're
understand.
finding W?
You're finding W, which is for some reason, that's a time. I would put a T there, but yeah. So that one's just kind of a nasty one. If you can get 3 to 4 points out of that, you are golden on something like that, because the next one, most of you should be able to get most of the points out of this, because it's what we just covered just a little bit ago. Okay? All right.
Calculator.
Find the sum of the two regions. This is a calculator question. So if you graph both of these, you can find their intersection point right here, right? We all know how to do that. Okay, we all know how to find the intersection. So the intersection point happens at 1.032832. Okay? So if you want to find the area of the two regions, you take the top minus the bottom and you write out your two integrals. Okay? You're going to get 4 points for this one. Okay? Because again, you all know how to do each and every part of this. Top minus the bottom from 0 to this, and then top minus the bottom from here to here.
Do we have to write it out?
Personally, I would write it out and not use their shorthand, but you're allowed to use their shorthand of top curve minus the bottom curve and so on. But I would write, I would write down the actual equation, because that's how I'm going to type it into my calculator to get my final answer. So I would write it all out personally, but they have shorthand where you can say, well, the G minus the F on that curve, and then the F minus the G on the other curve. Okay? So if you want to write down the shorthand, you can, but then, do the answer. But what I would do is write the integral from 0 to 1.032832 of, do not round it. Do not round it on the test, because that might throw off something a little bit. Okay? So then you might, it might throw off your answer and you lose one of your 4 points that you should be a gimme. Yeah. So, okay. And then if S, so we're looking just at part S, is the base of a solid where the cross section is x-axis is squares and it's perpendicular to the x-axis, so their squares going this way.
So it's G minus, or F minus G.
F minus G squared from your 1.032832 to 2. And you just do that integral. All of a sudden, you got 7 points out of this, because this is stuff we just covered. Okay? So this wasn't that long ago, and you kind of remember this stuff a little bit more.
So you square it, and then you have to integral it afterwards, or no?
Yeah, you integral it. You integral from here to here of the two functions subtracted from each other squared. So you put the squared around parentheses of everything.
You can plug that in again.
You can plug that in again. Okay?
So what numbers are you putting in there?
You're plugging
The same
in
equations.
the top equation minus the bottom equation.
And then square.
And you got to put parentheses and squared at the very end. Yep. And then,
Wait,
yeah.
what do
You put parentheses, you go parenthesis of I would go double parentheses of 1 plus x plus e to the x squared minus 2x, parenthesis, minus parenthesis, x to the fourth minus 6.5 x squared plus 6x plus 2, parenthesis, squared. Because it's squares. It's a volume of squares piled up on each other.
So you, okay, so.
Because that's the formula for finding the volume.
Dx equals, is that the answer?
Yeah, this is the answer. Yep. Okay. And then it says, let h be the vertical distance. Find the rate of which h changes. Rate of change. What do you think when you hear rate of change? That is slope derivative. So you're taking the derivative of h, which is this minus this. So you take the derivative at 1.8 minus the derivative at 1.8, and you get an answer. Again, this is the last part. This is part C. And if you go, well, they're derivatives, but I don't understand how to do it exactly. If you write down something with derivatives, hey, there's another point. So for this one, I would be getting like 8 of the 9 points and then make up for what I didn't get on that first question. Okay? So if you consider derivative when you see rate of change, they're throwing you a point. If you throw down integrals when they're talking about amounts, when you know they're supposed to be, they're giving you points. Okay? And when you see this, you got to think, what is this always? Riemann sum. Okay? You know there's going to be a Riemann sum in there. Okay. Estimate the value of the first derivative at 16. Derivative is what? Slope. Rate of change. Now 16, they don't give you a 16 here, but there's two things equally distanced away from 16. So you're just finding the slope. You're just finding the slope right there. 240 minus 200 over 20 minus 12. Finding slope. Slope is 5. Boom. You got an answer. Okay? Because the first derivative is slope. So you do slope. Then they say, use a Riemann sum to figure out her distance that she jogged. So then you do the Riemann sum thing. And I would put an integral in there just to get my extra point. It's because they ask you, what is this? So I'm going to say the integral of this and then write down the Riemann sum, but make sure it's a right Riemann sum. Because it tells you and asks you in the question right here. Look up. Right here. Right Riemann sum. So you go 12 times 200 plus and so on. Okay? And then because it's a distance, it's an absolute value, so you make sure you use your absolute values. This part of the problem is worth 4 points. So you can, totally cash in on this. And then the last couple are always a little bit harder as you get into these. Okay? Bob's riding a bicycle, finds Bob's acceleration. Ooh, Bob's velocity is this. His acceleration, what is acceleration compared to velocity? First derivative. So you take the first derivative and stick in a 5, and you get that. See how this kind of comes together? What I used to think was the scary part was the open-ended questions. They're really not that scary anymore because we've done this. And if you can think, okay, first derivative is slope and that and how velocity and acceleration and all that goes together, you can get points on this part. Okay? Position, velocity, acceleration, that order, derivatives, and then integrals go in the other direction. Yep.
Here's back, I got a question.
Yep.
So for number B,
Yep.
since it's negative, wouldn't it be 240 plus 220? Why isn't it 240 plus 220? I mean,
Because this is a negative, you mean?
yeah.
Because we're using the absolute value. Remember, it's an absolute value here. So we have to use absolute values of these numbers
Okay.
when we're doing our Riemann sum, because distance traveled is absolute value.
Yeah,
Of
that's
position.
why I wasn't from, but I understand. Can you just go to the next page now?
Yes?
Isn't it 4 times negative 220?
No, because it's the absolute value. Absolute value of a negative number is positive.
Why is it absolute value?
Because it's asking distance traveled, and distance traveled is the absolute value of position.
I hope that I would see a negative number and think they can't go backwards.
Yeah.
Wait, what?
Because they even tell you up here absolute value. So that if you see absolute value, you got to think, oh, take the absolute value of all those when I'm doing that. Okay? And the last one, average velocity during that. Well, average velocity is the integral of the position, and then average is 1 over the difference of the time. Okay? Which again, I think you can get. So a problem like this, I think you do pretty well on. Now, this one might not be a calculator problem. This one you might have to do multiplying and adding on your own on your piece of paper. Okay?
You wanna read that one? Wait, can you do that for a second?
How am I gonna know how to do, how,
What are they finding in them?
so I'm gonna have to multiply 4 times 24 just in my head?
Well, on your paper, yeah.
Why can't you just plug it in?
Because you might this might be a non-calculator question.
So I don't know what I'm doing then.
So I'm gonna take 10 times
Yeah.
40 times 6
I'm
times
taking
40.
the
Yep.
integral of that. The
Oh,
first
this is
one.
gonna suck.
So on this one, your right Riemann sum, it's like you're taking an integral, but your right Riemann sum is just this times this plus this times this plus this times this. Okay?
Am I gonna know what
Okay?
10,000
So where
So
are we
there-
plugging in 10 for T on that one?
okay, I'm gonna scroll through this really slowly. So then when you watch a video, you can kind of look at these if you have time to watch a video. But these are slope fields where you stick in the numbers for X and Y and you make a slope. That's not that hard. Stick in the numbers for X and Y and you get a number. If the number is like -2, you make your slope field look like this. If your number is 0, you make your slope field look like this. If your number is 1, you make your slope field look like this. Okay?
How would you know though?
Because you're sticking in numbers for X and Y. They give you an X and Y number, so you stick it into an equation to figure out the slope.
Oh, it'll just- okay.
Yeah, just plug and chug. All right, so do your best. Make sure your calculators are charged before the test. Monday morning, 8. So you need to be here 7:45, so you're ready to roll at 8.
We don't have to go to class after we do the test, correct?
You don't have to come to my class, but you have to make up stuff for other people's classes that you miss.
I have physics.
Yeah, it's lunchtime.
We're just making notes.
Yeah,
Bye. You too.